Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View Channel 972. You're always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 10 to 11 in the morning, and we are in our second week of our 9-week course. So just so you know what work to submit for marking, the pencil questions, the support questions with the pencil icon are not for marking. These are practice problems and you decide which ones and how many you need to do. If you're understanding concept, it's totally fine to skip a question, no worries. If you need more help, more practice, let me know and I'm happy to send you more practice problems. The answers are in the back of the booklet, so please check your work to make sure you are on the right track. The key questions, the ones with a little key icon, are the ones to submit for marking. So please do all of these questions. Show all of your work, your steps, and your thinking. This way I know what it is that you understand, and if you are making mistakes, I have more information that will help me actually figure out what it is that you are struggling with, and I can help. So how do you actually submit your work for marking? Well, there's 3 methods. The first is to scan your work and send it electronically. If you have a device, you can scan your completed work through the device. Apple devices have a Notes app, which has a scan function, and Android devices have a Google Drive app that has a scan function. These are free apps and are fairly straightforward to use. If you do need support learning how to use them, on my tech tutorials, there are 2 videos that will walk you through those how to use these scan functions. So go to my YouTube channel and check that out. If you need support, feel free to reach out and I'm happy to walk you through it. If you need to send pictures, because that's your only option, that's fine. Having them scanned just makes the files a little bit smaller and easier to do, but no worries if that doesn't work for you. Then send them to me through email at studentwork@nnec.owen.ca and cc to bronwyn.slate@nnec.owen.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our 74 Front Street location. We are the bright red building next to the post office and have a small white mailbox next to our side entrance. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also fax in their work. If you have access to a fax machine, that's fine. Just give us a call or send me a message to let me know that it is coming through fax, because sometimes things can get lost. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. You can friend me on Facebook and subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our videos. All of our radio Zoom classes are posted to the YouTube channel shortly after airing. And there's also short videos that explain common errors or confusing concepts on my YouTube channel. So that can be a good place to go and check things out if you're struggling with something and need some support. Math is a really visual subject, so I strongly encourage you to access the visuals. Either joining me live through the radio Zoom class or watching the YouTube channels are both great options. However, if you don't have reliable internet, this is not an option for you, let me know and I'm happy to send you a copy of the recordings so you still get the full experience. So if you have any questions or concerns, please reach out and connect with me. You can email me at bronwyn.slate@nnec.owen.ca. Connect with me through Facebook at B. Slate Wahsa. Call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I am happy to make accommodations if you need some support and those time frames don't work for you. I understand that. So just reach out and we can try to arrange something that works for both of us. All right, today's lesson is lesson number 4, and lesson number 4 needs to be done in 2 different radio Zoom classes, as there's a lot in them and they can be pretty confusing. So I've broken this lesson up into 2 parts so that we can really dive in and hopefully help for deeper understanding, opposed to just glazing over it really quickly. Our goals for this, our learning goals, are that you will be comfortable calculating simple powers and you will understand the logic behind your exponent rules. The success criteria, so that we know that we've met these learning goals, are that you can execute with comfort the multiplication, division, and power of power rules, and you can explain the reasoning behind zero and negative exponents. Today we'll be focusing on the first success criteria, and in our next lesson we'll be focusing on the second success criteria. Okay, so, but when will you use this in real life? How is this something that is actually beneficial for you? Well, we are developing the skills to attack problems. Exponents will show up in your life in some places, but being able to attack problems and problem solve definitely is going to be something in your life, whether it is math related or not. And so we are working on those skills. But first, let's activate your brain with some mental math. I don't believe in Mad Math minutes. I think that they focus on memorization and speed, which are not essential tools for math fluency and flexibility. So instead, we work on developing strategies that are based off of comfort and friendly numbers and transferable knowledge, things that are useful for you. So our question today is 24 times 24, and we're going to be using the strategy of doubling and halving. So this is the idea that we're going to double one number and cut the other number in half, because all numbers are products of factors, and we can then move the pieces around. So we have 24 times 24, so we have the same, doesn't matter which one we cut in half and which one we multiply by 2, because they are the same number. So we're going to multiply 1 by 2, which 24 times 2 doubled is 48. And 24 divided by 2 is 12. So 24 times 2 is the same thing as 48 times 12. Well, that is not any very friendly, so I'm going to do it again. So 48 doubled is 96, and 12 cut in half is 6. So this is still double. This, we're still multiplying 96 times 6 is the same as 24 times 24. So then, but that still isn't particularly friendly. So I'm going to double 96. So 96 doubled. Well, 96 is really close to 100. So 100 doubled would be 200. So I know I'm going to be really close to 200, but I'm going to be 4 away for each group of 96. So that means I'm going to be 192. And half of 6 is 3. So now I can't divide 3 in half again. Well, I can, but I will get a decimal. I will get 1.5, which isn't the friendliest of numbers. So instead, I'm going to just try to triple. I'm going to now do 192 times 3. Well, 192 is really close to 200, like we said before. So 200 times 3 would be 600, but that's an extra 8 for each 192. So 8 times 3 is 24. So it's going to be 600 take away 24, which is going to be 586. So 24 times 24 is 586. Now, this is still a few steps, but it can make a little bit more sense about how we got there. And it isn't necessarily a strategy you want to use every time, but it can be something that can be useful sometimes. All right, mine's on. What prior knowledge do we need? I just want to remind you how exponents work. Hopefully this is not the first time that you've experienced exponents, but let's remember how they function. So this, on my picture, I have a blue ellipse, squash, circle, oval. Sure, let's call it an oval. That's the easiest term. And that is our base. So this number that is in this space, in this blue space, is going to be a big number here. This is going to be, this is our base. Then the exponent is going to be this little number here where I have this star. This is going to be your little number that is a superscript that is up to the top right corner is your exponent. So it's important to realize that the position and the size of these numbers matter. They make a difference. Okay, so then this whole thing is called a power. So the combination of the base and the exponent, this whole thing is called a power. So an exponent, the job of the exponent is to tell you how many times the base number, the base value, is being multiplied by itself. Okay, so what does that actually mean? So we need some numbers in order for this to make sense. So if we, instead of having our star, if we put a 5, that means that we're multiplying our base by itself 5 times. We are not multiplying our base by 5. We are multiplying our base times our base times our base times our base times our base. That's what an exponent means. It means that we are doing this multiplication. We're having 5 versions of this number, this base, is being multiplied together. Folks often multiply the exponent by the base. That is not accurate. That would just be multiplication. That's not, this is a shorthand to show how to multiply the same number by itself over and over and over again. Okay, so then what else do we need to remember? Let's look at what this means with numbers. So 4 to the exponent 3 is equal to 4 times 4 times 4. 2 to the exponent 8 is 2 times 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 2. Use your fingers, totally use your fingers to help keep yourself organized. I do it all the time. -7 to the exponent 4 is -7 times -7 times -7 times -7. So it's important to recognize where that negative is. Calculators sometimes do this. If you just have -7 to the exponent 4, they are going to do 7 to the exponent 4 and then the negative. So using your brackets can be really important. What this means with variables, well, x to the exponent 5 is x times x times x times x times x. As you can see, if we use a multiplication sign when we are multiplying x's, it's really kind of confusing because they just look like we have big x's and little x's. So when we're using variables, the notation that we use is a little dot. So this little dot that we have between means multiplication. And I'm going to be using that today in this lesson. So it's important to remember that this little dot between our variables, even if it's between our numbers, it means multiplication. That's what I'm going to be doing. It is not a decimal place. It is not along the bottom. It is centered partway up it's hanging in the air, floating in the air is how I visualize it between our variables. A squared is equal to a times a. T to the exponent 10 is t times 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 t. You can see why having the notation t to the exponent 10 any of these is useful because we don't have to write out as much or say as much, though it means the same thing. It's just new notation. It's just something to make it easier for us to communicate our ideas. So then figuring out where this button is on your calculator, this is really important. Many folks have used the squared button. So when your exponent is at 2, that's something you most likely are familiar with. So this usually on your calculator is x to the exponent 2, or y to the exponent 2, a to the exponent 2, b to the exponent 2, some sort of variable to the exponent 2 is pretty, most people can find that. But if you want to have a different exponent other than 2, then you need a different button. So any of these buttons that I have on the screen or some sort of variation of these are most likely their exponent button. So x to the exponent y or y to the exponent x, a to the exponent b, maybe b to the exponent a. It could be any combination of these variables. The other page is, or sorry, the other button that it could be this little hat that I can never remember the name of, and I need to look it up again. But this little like top of a triangle or this little hat is the like computer science way of writing exponents. So you could have that on your calculator. It also could be, it's a button that is like if you press Shift and 6 on your keyboard, that is the symbol. So if you're reading something online and you see that symbol, that means the exponent. You can also use that if you're using an online calculator. So something to get comfortable with depending on your needs. Okay, so that's our reminder of setting ourselves up for success about the tools that we need that we should have already had before. But let's dive into our new concept today. So first, we're going to be talking about our rules for multiplying powers. And this is on page 26 of your IEL booklet. So how do we multiply powers with the same base? So if we have 2 to the exponent 4 times 2 to the exponent 3, well, if we expand this out, this means that we have 2 times 2 times 2 times 2 times 2 times 2 times 2, right? We have one group where we're multiplying 2 by itself 4 times, and we have another group where we're multiplying 2 by itself 3 times, and we're multiplying that all together. So really, that means that we're just multiplying 2 times itself 7 times, because the fact that we're doing one as a group first and then the other doesn't actually matter in terms of multiplication. Multiplying is what's called commutative, so the order of multiplying doesn't matter. It doesn't change anything. So really, this means that we have 2 to the exponent 7, because we have 7 2's that we're multiplying by itself. Okay, so we could also, what we're doing with a rule is we're developing a shortcut. What is making our life a little bit easier so that we don't have to write out all of these 2's. So 2 to the exponent 4 times 2 to the exponent 3 is really the same as 2 to the exponent 4 plus 3, right? Because we just have one group where we have 4 2's and one group where we have 3 2's. And then that means that we actually have all together, we can add those groups to figure out that we have 7 2's altogether. So the rule for multiplying powers is that we add our exponents. So let's see if we do that with variables. We have x to the exponent 2 times x to the exponent 6 is equal to x times 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 x. So that's still, again, we just now have a total of 8 x's instead of having 2 x's first and then 6 x's. We can just think, well, really, we just have 8 x's. And so we have x to the exponent 8. So that still works. So our shortcut, x to the exponent 2 times x to the exponent 6 is equal to x to the exponent 2 plus 6, which is equal to x to the exponent 8. This still works. So our multiplying powers rule is that we multiply powers with the same base, then we add the exponents. But I've been saying this a couple times that we must have the same base. And why is that? Why is that important? So let's look at an example where we don't have the same base. So 1 to the exponent 3 times 9 to the exponent 2. So we don't have the same base. We have a base of 1 and we have a base of 9. But let's expand that. So 1 to the exponent 3 is 1 times 1 times 1, and 9 to the exponent 2 is 9 times 9. So now if we were trying to combine them, does that make any sense? 1 times 1 times 1 times 9 times 9. Do we have 5? We have 5 things, but we have 5 of the same things? No, we don't. So we can't combine them. We can't add our exponents because we don't have this. We're not talking about the same thing. It doesn't make any sense. The reason that we can add our exponents when the base is the same is that we're talking about the same thing. So it just doesn't make any sense. We can't add our exponents if our base is not the same. Now, you're most likely not going to do that with numbers. That's not going to make you any sense, but lots of people do it with variables. So you have x to the exponent 4 times y to the exponent 7. That means we have x times x times x times x, times y 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 times y. And when we expand it, does it make sense that we have 11 of the same thing? If we have 4 x's and 7 y's, do we have 11 of the same thing? No, we have 11 things, but we don't have 11 of the same things. So it doesn't make any sense for this to turn into x to the exponent 11 or y to the exponent 11. We don't have 11 of either one of those things. So this is why the base must be the same, because we're just saying that we have the same thing. We can just combine the exponents because we're talking about the same thing. If we don't have the same thing, we can't combine exponents because we're not talking about the same thing. So hopefully that makes sense for you. Okay, let's do a little bit of practice to get this making a little bit more sense. So we have a number 1, simplify. So when it says simplify, this means we don't need to evaluate. We are just going to combine our exponents as much as we can. So we have our part A is 3 to the exponent 2 times 3 to the exponent 4 times 3 to the exponent 3. So here I have the same base. That's the first thing I check. So that means that I do 3, and I can do this all at once. I'm multiplying. So I can do, well, that's 3 to the exponent 2 plus 4 plus 3. So 2 plus 4 is 6 plus 3 is 9. So 3 to the exponent 9. So this simplifies to 3 to the exponent 9. I just have one power. That makes my life a little bit easier. Okay, part B, we have negative y to the exponent 2 times negative y to the exponent 3 times negative y to the exponent 9. So that means I have negative y to the exponent 2 plus 3 plus 9. 2 plus 3 is 5, plus 9 is 14. So I have negative y to the exponent 14. Again, that's as far as I can simplify at this point. That's the only tool that I have. Okay, then if my base is a fraction, so I have 3 over 4 to the exponent 5 times 3 over 4 to the exponent 3. Well, my base is still a fraction. That doesn't change my rule. My base is still the same thing. So my base is still the same thing, and I'm multiplying. I still just add my exponents. So that means I have 3 over 4 to the exponent 5 plus 3, which is equal to 3 over 4 to the exponent 8. And that's all that I know how to do right now. So I'm done. I'm good to go. And part D, we have n to the exponent 6 times m to the exponent 2 times n to the exponent, or to no exponent, which means it's exponent 1, right? There's an invisible 1. We're too lazy to write it. I just have one n, and times m to the exponent 5. So here we've got 2 variables. That means we have 2 bases. We can't combine all of these together, but we can combine the n's and we can combine the m's. So I'm just going to rewrite it. And remember this, so I have n to the exponent 6 times n. Remember that n is to the exponent 1. So I'm just going to write a 1 there to help me remember. Times m to the exponent 2 times m to the exponent 5. So that means I have n to the exponent 6 plus 1 times m to the exponent 2 plus 5. So that equals n to the exponent 7 times m to the exponent 7. This is random that they're both 7, just because of the numbers that I randomly picked. I cannot simplify this further because I don't have the same base. All right, so that is multiplying powers. Now let's look at dividing powers. Again, this is on page 26, and we're going to be looking at how to divide powers with the same base. So 8 to the exponent 6 divided by 8 to the exponent 3. Well, let's explain what that looks like. So that means that we have 8 times 8 times 8 times 8 times 8 times 8 divided by 8 times 8 times 8. We can write it like this, or we can rewrite it in the fraction model of division, which is what I like to do, which it makes it's easier to visualize in my head. You do not need to write it this way. If writing it linearly makes more sense for you or is fine for you, totally fine. This is just another option. Still the same, where we have 8 times 8 times 8 times 8 times 8 times 8 divided by 8 times 8 times 8, whether or not I'm writing it with the division symbol or if I'm writing it with one over the other, kind of looks like a fraction, that division. Okay, so now what? Well, when I'm multiplying and dividing, again, I can think, well, if I'm multiplying something by 8 and then I divide it by 8, that doesn't change anything. That's just like multiplying it by 1, because if I increase something 8 times and then I divide it by 8 times, I haven't actually changed it. So those 8s can cancel off. But I can do that more than once. I can do that a second time, and I can do that a third time because I'm dividing by 3/8 and I have 3/8 that I was multiplying by. So that means that really those all we're going to cancel each other off. So I'm left with 8 times 8 times 8 divided by 1, which is just 8 times 8 times 8, which is 8 to the exponent 3, because I'm left with only 3/8 that I'm multiplying. So the shortcut way of this is to think about it is 8 to the exponent 6 divided by 8 to the exponent 3 is equal to 8 to the exponent 6 take away 3, which is equal to 8 to the exponent 3. So because they cancel each other off, we can take them away from our power where we are, so that because we're multiplying less together. If that makes any sense. Okay, let's look at it with if we have a variable. So I have b to the exponent 9 divided by b to the exponent 7. Again, this is just a different way of writing it, but it's still division, is equal to b times b, my computer issues. Sorry, b times 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 b. That's 9 b's divided by b times b times b times b times b times b times b, which that's 7 b's. So again, if I'm multiplying by a b and then dividing by a b, they can cancel off. And then I can just keep canceling them off, one from the top, one from the bottom, until I run out of ones on either the top or the bottom. Here I've run out, and so I'm left with b times b divided by 1. So I have 2 b's left, and so b to the exponent 2 is what my power simplifies to be. So again, the shortcut, b to the exponent 9 divided by b to the exponent 7 is equal to b to the exponent 9 take away 7, which is equal to b to the exponent 2. So if I am dividing my powers with the same base, then I subtract the exponents. That is a shortcut that makes it a little bit simpler. Okay, but again, remember the same rule, the same reason why the base needs to be the same, because if the bases are not the same, then we're not talking about the same thing. So this dividing power only works, the dividing power rule only works if we have the same base. Okay, so let's look at some examples. So we're going to again simplify. This time we have part A is z to the 14 divided by z to the 3rd. So that is equal to z to the 14 take away 3, which is equal to z to the 11th. And that's all we do. Part B is -2 to the 9 divided by -2 to the 2 divided by -2 to the 4. We have the same base, so that means we have -2 to the exponent 9 take away 2 take away 4, which is equal to 9 take away 2 is 7, take away 4 is 3. So -2 to the exponent 3. Okay, part C, now we have a whole bunch of variables. Looks a little confusing. So we have w to the 8th times x to the squared 2 times y to the 5th divided by w to the 3rd, y to the 4th. So again, we combine things that have the same base. So just because we have multiple parts, multiple variables in this, doesn't mean we can't look at what we have as the same base. So w, well, we have w to the 8th, and then it's going to be divided by w to the 3rd. So we're going to do 8, take away 3. And then we have x squared. And then do we have any x's, any more x's? No, we don't. So we don't have any like terms. We don't have anything else with a same base. So I'm just going to leave x squared. And then we have y to the 5th divided by y to the 4th. So we have 5 take away 4. And now we simplify. W to the 8th take away 3 is w to the 5th. X we didn't have to do anything else with, so it's still x to the squared. And y, 5 take away 4 is 1, so we can just leave y without an exponent. If you put it a 1, that's totally fine. I will accept it. Mathematicians are lazy, so I don't need to put the 1 because I just have one y, so I won't do it because I'm lazy. Okay, part D. Here we now have numbers as well as variables. So we have 2 to the exponent 5 times n to the exponent 8 divided by 2 to the exponent 3 times n to the exponent 6. So that means we have 2 to the exponent 5 take away 3 is our one common base, and then n to the exponent 8 take away 6, which is our other common base. So we have 2 squared and n squared. Most likely for this one, because I have a number, you could leave it here. That's technically right, but I most likely would simplify this further and do 2 squared, which is 4, and then n squared, because I can't simplify the n squared anymore. Because that's just a little bit nicer to look at and get some more information, whereas this doesn't. 2 squared seems like I can make it simpler, which is 4. All right, so now power to a power rule. So what does it mean if we raise a power to a power? Again, this is on page 26. Your IL booklet doesn't go through it in too much detail, which is why I'm going through it in lots of detail, hopefully so it makes more sense. Okay, so what that means, if we're raising a power to a power, it means we know that a power means that we have an exponent. So we have something, so my base, and I've raised it to an exponent. Okay, so we know that that means that I have my base times my base times my base times my base times my base. My base to the exponent 5, that's what it means. But what if my base is 4 to the exponent 2? That means that every time I have my base is 4 to the exponent 2. So I have 4 to the exponent 2 times 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 4 to the exponent 2. Okay, but 4 to the exponent 2 is just 4 times 4. So that means I have 4 times 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 4. Okay. So that means that I actually have 4 times itself 10 times. So really I have 4 to the exponent 10. Okay, so let's see if we can look at the shortcut to figure out where that comes from, or what we can do to simplify all of those steps. So 4 to the exponent 2 to the exponent 5 is equal to 4 to the exponent 2 times 5, because first I have the base 5 times, and then each of those 5 bases has a base that I'm multiplying by itself 2 times. So really, I'm doing it 2 times 5 times. So we really have 4 to the exponent 10. It can be tricky. Give yourself some time to practice. Okay, let's look at it with a variable. So if we have y to the exponent 9 to the exponent 4, this means that we have y to the exponent, we have our base to the exponent, sorry, we have our base times itself 4 times. But our base is y to the exponent 9. So we have y to the exponent 9 times y to the exponent 9 times y to the exponent 9 times y to the exponent 9, which is really just y times itself 9 times y times itself 9 times y times itself 9 times y times itself 9 times. I'm not going to say all those y's. There are too many. I'll get confused. But if I do that all together, then I have 36 y's. So really, we can simplify this to be y to the exponent 36. And if we look at our shortcut, y to the exponent 9 to the exponent 4 is equal to y to the exponent 9 times 4, which is equal to y to the exponent 36. And that's the power to the power rule. So when you are raising a power to another power, when you have an exponent, you have a base with an exponent, and then you have another exponent that on top of that, then you are multiplying the exponents. In order for this to happen, you can see that we have to have brackets so that we know that we're not raising to the exponent 94. We have to have our base in brackets, and then we have another exponent. So we're multiplying our exponents when we have a power to a power. In this case, we don't have to have the same base because we only have one thing. So we do have the same base. It's just that it's hidden because we're only talking about one thing. All right. So what happens if we have a whole bunch of things inside of our base, which could happen? So for this example, we have -6 times x to the 4th times y to the squared times z, and all of that is to the exponent 3. So don't let yourself get confused and overwhelmed because there's lots going on there. Think back to the basics. That exponent 3 means that we're multiplying whatever's inside the bracket by itself 3 times. So we can just think that we're doing this 3 times. Then we say, okay, well, what is that base? Well, the base is -6 x 4th x squared z times -6 x 4th x squared, sorry, y squared z times -6 x 4th y squared z. So that's just our base times itself 3 times. And then because everything's multiplying, remember when we don't have a sign between letters and, or sorry, variables and numbers, we're multiplying again to simplify things. So this means that we can collect all of our like bases because we want to combine bases that are the same. So we have -6 times -6 times -6. And then we have times x to the 4th times x to the 4th times x to the 4th times y squared times y squared times y squared times z times z times z. And remember, both for the z and the -6, they don't seem to have exponents, but they do. Their exponent is just 1. And because mathematicians are lazy, we only have one thing, so we're not going to write it down. So that means we have -6 to the exponent 1 times 3 times 4 to the exponent, sorry, times x to the exponent 4 times 3 times y to the exponent 2 times 3 times z to the exponent 1 times 3, which is equal to z. It's confusing when you have lots. Is equal to -6 to the exponent 3, x 12, y 6, z 3. So each of the things inside the base, the exponent gets applied to each of them. The power rule applies to each of those individual bases. And then we can simplify that further with our numbers like we did with the 2 squared. We have -216, which is -6 to the exponent 3, x 12, y 6, z 3. And that can get confusing, but that's how it works. So just take it part by part, step by step. If we have a fraction where we are raising a power to a power, the same thing applies. So first we have 2/5 to the exponent 3 to the exponent 2. So 2/5 to the exponent 3 times 2/5 to the exponent 3 is what we are multiplying. So that is equal to 2/5 times 2/5 times 2/5 times 2/5 times 2/5 times 2/5. So that really is just 2 times 2 times 2 times 2 times 2 times 2 over 5 times 5 times 5 times 5 times 5 times 5. So that's 2 to the 6 over 5 to the 6. So when you have a fraction, you can apply the exponent to both the numerator and the denominator in the same way, because you're doing the same thing over and over again with the same base. So the shortcut for with a fraction is that you're still doing exponent a power to a power, so you're still doing multiplication, but then you're applying it both to the top number and to the bottom number, to the numerator and the denominator. So you go from 2 over 5 to the exponent 3 to the exponent 2 is equal to 2 over 5 to the exponent 3 times 2, which is equal to 2 to the exponent 3 times 2 over 5 to the exponent 3 times 2, which is equal to 2 to the exponent 6 divided by 5 to the exponent 6. It's tricky, do some practice. Okay, so let's do some practice together. So simplify part A, 5 to the exponent 2 to the exponent 7. So this is equal to 5 to the exponent 2 times 7. This is why it's important to remember which are the big numbers and which are the little numbers. So 5 to the exponent 2 times 7 is 14. We're good to go. Then part B, -3 to the exponent 8 all to the exponent 6 is equal to -3 to the exponent 8 times 6, which is equal to -3 to the exponent 8 times 6 is 48. Then we have -a to the exponent 4 to the exponent 7. So we have -a to the exponent 4 times 7, which is equal to -a to the exponent 28. And then we have r divided by t to the exponent 3 all to the exponent 9 is equal to, well, r over t is our base to the exponent 3 times 9, which is equal to r over t to 27, which is fine. I would accept that, or I would accept r to the 27th over t to the 27th. Both of these are accurate, and it's hard to know which one would be more useful in the situation. And that is the power of the power rule. Okay, so now you can do the support questions on page 20, but you can only do questions 1B, H, and 2D with the skills that we've used. There are negative exponents and zero exponents in all of the other problems, which we're going to look at in our next lesson. There's also these other rules that we've applied, but they mix them all up and use them in the parts. So just to practice just these 3 rules, you can only do 1B, H, and 2D. To do the rest, wait until we wrap up this lesson in our next session. Okay, so we have a couple minutes to do a couple of practice questions. So first, it's important to understand what the question is asking for. So if it's asking you to evaluate, it's asking you to calculate a final answer. So you should have a number at the end. Whereas if you're simplifying, you're combining your exponents as much as you possibly can, which is what we've been doing so far. So let's do a couple of evaluation questions just to make sure that we know what we're talking about. And we know how to use our buttons on our calculator. So part A, 6 to the exponent 4. So I don't want you to be doing 6 times 6 times 6 times 6. I want you to be using your calculator, whether it's Desmos or something else, and saying, okay, so 6, and here you can see a to the exponent b is my exponent button, and it sees my calculator has shifted it, so I'm up in the exponent 4, and I get 1,296. So 1,296 is evaluating. That's all you need to do for the evaluation questions. This is just calculate the answer using your calculator to make sure you know how to use your calculator. Okay, part B, -5 to the exponent 3. So again, using our calculator and making sure that you're putting the negative in the right place. You can play around with your calculator to see. So if I do it the way that it's written, -5 to the exponent 3 with brackets, I get -125. Now, I'm not sure if this calculator, if I don't put the brackets in, this one I still get -125, which is accurate, which is true. Sometimes calculators, even if you don't put the brackets in, like I'm putting the brackets in right now, they will, oh, but it's because yes. Sorry, I'm just confusing you. Never mind. Just be careful with your calculator. Pay attention to your calculator. This question doesn't help us. So understand what I'm trying to explain. So -5 to the exponent 3 is -125. Here we have 7 over 9 to the exponent 2. So 7 is still going to be 7, and 9 to the exponent 2 is 81. So it's going to be 7 over 81. If I could simplify this fraction, I would. I can't, so I won't. And here we have 2 over 3 to the exponent 4. So again, we are using our calculator. We're not using our rules. We're just evaluating. So I have 2 divided by 3 in my brackets, and I want it all to be to the exponent 4. And so I get 0.1975, which you write down, or you can put it in a fraction, which is 16 over 81. Either is acceptable depending on what's more useful for you. And that's how we evaluate questions. So then if we are simplifying, now I'm going to combine some of the rules together, so we need to be paying attention. So for part A, we have 3 to the exponent 8 times 3 to the exponent 2 divided by 3 to the exponent 4. So that is equal to 3 to the exponent. Well, here I'm multiplying. Okay, first off, I have all the same bases, so I can do all the rules. So I'm multiplying, so that means that I'm doing 8 plus 2, and then divided by 3 to the exponent 4 is equal to 3 to the exponent 10, and then take away 4, which is 3 to the exponent 6. You could also do this all in one step, where you could do 3 to the exponent 8 plus 2 minus 4, because we're dividing 4, and you get 3 to the exponent 6. Whatever works best for you in terms of making sure that you know what you're doing is totally fine with me. Okay, so then part B, we can also have decimals as our bases, totally legit. So we have 0.2 to the exponent 3 to the exponent 5 divided by 0.2 to the exponent 6 to the exponent 2. So our base doesn't change our rules. Just because it's a decimal, we haven't seen decimals, it doesn't change our rules. Our base is 0.2. It's the same in both places. Our base is the same. We can apply the rules. So I have 3 times 5 divided by 0.2 to the exponent 6 times 2. So I have 0.2 to the 15 divided by 0.2 to the 12 is equal to 0.2 to the 15, take away 12, which is equal to 0.2 to the third. You could do this in one step instead of a whole bunch of steps. Either way is fine as long as you're tracking and you understand what it is that you're doing. Then you can also have really messy, big, scary ones like this, which can be overwhelming, but you just need to do in the parts that you have. So we have 8 times x seventh y cubed z squared times 3x squared y to the fifth z, all divided -6 times x times y to the fifth z squared. So what we're going to do is we're going to bring our like bases all together. So the numbers are not like bases, but are still numbers. So we're going to bring them together because they're numbers. So then I have on the top, I have x to the 7 and x 2 squared. So they're going to add them together. And then I have, so I can then take away 1 because I'm dividing by 1. And then I have y3 plus 5, take away 5. And then z2 plus 1, take away 2. So 8 times 3 is 24, divided by -6 is going to be -4. Then x, 7 plus 2 is 9, take away 1 is 8. Y3 plus 5, take away 5 is 3. And z2 plus 1, take away 2 is 1. And so then I can just simplify all the way to that. So just paying attention to each of your little parts and each of your individual bases is really important. Also, you can do it in more steps if it makes sense to do it in more steps. Do what makes sense for you. And then finally, we have part D, x to the exponent 2 to the exponent 4 times 3x to the exponent 5, all divided by 6 to the exponent 10. Sorry, 6 times x to the exponent 10. So here we're going to do, well, 3 is our number and 6 is our number. So we're going to bring our numbers over to the front. Then we have x 2 times 4, and then plus 5, and then take away 10. That's me doing it all in one step, which you don't have to do, but you can. We're running out of time, so I'm doing it. 3 over 6 is 1/2. Then x is going to be 2 times 4 is 8, plus 5 is 13, take away 10 is 3. And this one you could write as 1/2 x cubed, or you could write x cubed over 2. Both are fine. Both are acceptable. So the really gross ones can be simplified just looking at the parts and remembering the rules. All right, we don't have time to go through these couple other ones that are a little bit more complicated, but try them out. And if you have questions, reach out and we can talk through those ones if need be. All right, so let's consolidate our learning. What did we learn today? So we did the first part of lesson 4, which is exponent laws. The key part for this is that you need to have the same base. Super, super important. Base needs to be the same. The multiplying power rules is that you add the exponents when you are multiplying 2 powers with the same base. So x to the exponent a times x to the exponent b is equal to x to the exponent a plus b. The dividing power rule is that if you are dividing powers with the same base, you subtract the exponents. So b to the exponent x divided by y, b to the exponent y is equal to b to the exponent x minus y. The powers of a power rule is that if you have a power to a power, you multiply the exponents. So t to the exponent n to the exponent p is equal to t to the exponent n times p. All right, so as I said, we only have covered success criteria. Number 1 is that you can execute, hopefully with comfort, the multiplication, division, and power of power rules. This stuff takes practice, so please do the practice problems, check your work with the answers, and ask questions if you're struggling with anything. We will continue the rest of lesson 4 and do the other rules in our next session, so come back for that. So that is the first part of lesson 4 today. As always, if you have any questions or concerns, please reach out and connect with me. This is why I am here. Call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. Email me at bronwyn.slate, that's spelled bronwyn.slate@nnec.on.ca. Connect with me through Facebook at bslatewahsa or YouTube at bslatewahsa. All of our lessons are under a playlist called MBF3C, which is our course code, so you can find lots of resources there. I'm in the office Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 until 11, so that's not a great time to get a hold of me. But if you want to connect and those hours don't work, let me know by voicemail or an email or something, and we can try to figure out something that can work for both of us. Thank you so much for joining me today. Mogwitch.